Hi everyone and welcome back to another lab. Today we will walk you through the process of configuring and verifying the Link Layer Discovery Protocol, which is LLDP. We will start with a brief overview of what LLDP is and how it works. Next, we will discuss the disadvantages of using LLDP. After that, we will outline the lab objectives, review the lab topology and the lab tables, and walk you through the lab tasks as well. Finally, we will guide you through the solution step by step. By the end of this session, you will have a thorough understanding of LLDP and how to use it effectively in your network. This lab will also help those that are looking to obtain the CCNA qualification. So first things first, what is LLDP? So LLDP stands for Link Layer Discovery Protocol. It's a vendor neutral layer 2 protocol used by network devices for advertising their identity, capabilities, and neighbors on a local area network. This protocol helps in network management and troubleshooting. Unlike Cisco Discovery Protocol, which is CDP, which is proprietary to Cisco devices, LLDP is standardized by the Institute of Electrical and Electronics Engineers, which is the IEEEs. This means it can be used on equipment from different manufacturers. LLDP operates at the data link layer, which is layer 2 of the OSI model, which means it doesn't depend on network layer protocols like IP, and it uses Ethernet frames to transmit information. So devices that are using LLDP sends out periodic advertisements known as LLDP data units or LLDP DUs to directly connected neighbors. These packets contain information about the sending device. Regarding the LLDP data unit components, it contains the chassis ID, the port ID, the time to live, and the type length values that include system name and description, port description, capabilities, and management address, and these are flexible fields. Okay, with that being said, let's dive into how LLDP works. When LLDP is enabled on a device, it starts sending LLDP DUs out of its interfaces at regular intervals. The default interval is usually 30 seconds. Devices also listen for LLDP DUs from their neighbors, and when a device receives an LLDP DU, it stores the information in a table called the LLDP neighbor table. The collected information can be accessed by network administrators to understand the network topology, identify the devices, and troubleshoot connectivity issues. Now, let's quickly discuss the disadvantages of using LLDP. So, using LLDP can introduce security risks by exposing information about your network devices, which it can be exploited by malicious users. If an attacker gains access to the network, they could use LLDP information to map the network and identify potential targets. LLDP does not include mechanisms for authentication or encryption. This makes it vulnerable to spoofing attacks, where an attacker sends fake LLDP packets to mislead devices and administrators. Also, by using LLDP, there will be additional traffic, although the amount of data is relatively small. In large networks with many devices, this can contribute to the overall network load. We also need to include the processing LLDP packets consumes CPU and memory resources on network devices. In high traffic environments, this might impact the performance of devices with limited resources. LLDP requires manual configuration on each device. If not configured correctly, it might not provide the expected benefits or could lead to incorrect network maps and troubleshooting data. Okay, so with that being said, let's discuss how to mitigate these disadvantages. The first thing you should do is to restrict LLDP use. For instance, enable LLDP only on necessary ports and devices, especially on network edges where exposure to unauthorized devices is minimal. You can use network segmentation by using VLANs and other network segmentation techniques to limit the broadcast domain of LLDP packets. adjust the LLDP advertisement intervals based on the network size and stability to balance the need for up to date information with the desire to minimize traffic. Okay, so let's move into the lab objective. So our objective for this lab is to configure and verify link layer discovery protocol on Cisco switches and routers. So we will enable LLDP globally across all devices in the network topology you can see on the screen. We will configure LLDP on interfaces and disable the feature on the interfaces that are either down or facing the end hosts. We will also verify the LLDP configuration and examine the output. With regards to the lab topology, we have four different departments. We have the IT department that resides in VLAN 10. We have the HR department that resides in VLAN 20. And we can see that we have the sales department that resides in VLAN 30. And finally, we have the research department that resides in VLAN 40. VPC1 is connected to switch 1, whereas VPC2 is connected to switch 2. Similarly, on the other side, VPC3 is connected to switch 3, and VPC4 is connected to switch 4. We can see that switch 1 and switch 2 are interconnected via Gig Ethernet 00, and both of them are also connected to router 1. We also can see that switch 3 and switch 4 are interconnected with each other via Gig Ethernet 00, and both of them are connected to router 2. Router 1 and router 2 are interconnected with each other via Gig Ethernet 00. Just to let you know that this lab has been pre-configured. For instance, switch 1 has a couple of VLANs. These are VLAN 10 and VLAN 20. The links facing the end host and router 1 are configured with the appropriate VLAN and access mode. The link facing switch 2 is configured with static trunk, and the same applies across all switches. Each switch is configured with the appropriate SVI for management purposes. In terms of router 1 configuration, all connected interfaces are configured with the appropriate IPv4 address, and a static route was configured to forward traffic that are unknown networks to router 2. And the same applies for router 2. All connected interfaces are configured with the appropriate IPv4 addresses, and a static route was configured to direct or forward unknown network to router 1. So regarding the lab tables, the first table we are tackling is the router IPv4 address table. And as you can see on the screen, the table presents detail regarding devices, interface configuration, and IPv4 address information. For instance, we can see the device name. This column lists the name of the network device, whereas the interface ID column displays the unique identifier of the interfaces on the respective devices. The IPv4 address or the IP address column that shows what each interface will utilize which IPv4 address. And then finally, we can see the subnet mask that dictate how big is the network address. Regarding the switch VLAN table, the table presents details regarding devices, interface configurations, and associated VLANs. The device name and the interface ID columns are similar to what we discussed in the table above. We can see the interface mode. Here it indicates the operational mode of each interface. It specifies whether the interface is configured as trunk or access. And finally, we can see the allowed VLANs, and this columns enumerates the VLANs associated with each interface. It lists the VLAN IDs assigned to the respective interfaces, indicating the VLAN membership of each interface. If the interface is operating in trunk mode, that means we will use the allowed VLANs information under that column. Moving to the SVI table, again, this table is similar to the router table, but in this case, we will be using a logical interfaces on each switch to assign an IPv4 address for management purposes. For instance, switch 1 will have an SVI 10 with the following IPv4 address 192.168.10.11, and the subnet mask is going to be 255.255.255.0, which is equivalent of /24. Finally, the end host IPv4 address table, and this is just for your information. In this lab, we already configured each VPC end host prior to the lab with the information you see on this table. For instance, VPC1 will have 192.168.10.100 and with the following subnet mask /24, and is going to reside in VLAN 10 and is already be pre-configured with the default gateway of 192.168.10.10. So regarding the lab task, as you can see on the screen, the first task, we will enable LLDP globally across all devices in the network and enable all interfaces on both routers. We will view the LLDP neighbors on switch 1 and switch 2 and router 1 once obviously the network has been converged. And we will answer a few questions based on the tasks that you see on the screen. For instance, we're going to define what are the neighbors that are displayed, what is the neighbor's interface ID, and what are the capabilities of each device. We will also execute the appropriate command to determine the neighbor's iOS type and version. And then we will move into step 3, where we are going to issue the appropriate command to display the LLDP global information. And we will also answer a few questions, such as what is the current LLDP status, how often does the LLDP by default sends the hello message, etc., etc. We move to step number 4, where we're gonna tackle this task, which is what we're gonna do on switch 1 and switch 2. For instance, we will issue the command that changes the LLDP advertisements interval to 60 seconds. And we will also answer the question, why would you change the default settings? We will then move to step 5, where we're going to do further configuration changes for LLDP. For instance, we're going to change the hold down interval to 180 seconds. And also we need to answer the question of why would you change the default settings for the hold down interval. We then move to step 6, where we're going to perform some in-flight checks to verify our configuration and examine the output. Then we move to step 7, where we're going to shut down the Gig Ethernet 00 interface on switch 1. And then we'll move to switch 2 or step 2, where we're gonna wait for the LLDP to reconverge, and then we're gonna issue the appropriate command to display the LLDP neighbors, and then we're gonna find out how long we have to wait until the entry is removed from the switch, and then examine the output, etc., etc. Then we move to step number 9, where we're going to enable the interface back, where we're going to unshut the interface and wait for LLDP to converge. And then we move to step 10. And step 10, we are going to disable LLDP across all interfaces that are facing either the end hosts or the interfaces that are down. And then we move to step 11, where we're going to tackle Gig Ethernet 00 on routers 1 interface. So we're going to disable LLDP from sending hello messages and enable the interface to receive LLDP hello messages from router 2. And then we're going to examine the output. We will do some in-flight checks. We're then going to ping from VPC1 to VPC4, and we will check if the ping is successful. And then finally, we're going to save our configuration across all devices, and that will be the end of the lab. So, okay, this is the moment where I ask you to pause the video and give this a go yourself to test your knowledge and skills. So I added the lab document in the video description so that you can download it and practice it at your own pace. I have also included a couple of ieverythingeverywhere labs for you to download. You will find a pre and a post version of the lab. And the pre-lab is for those who wants the lab ready to go and tackle all the tasks. And the post-lab is for those who wants the full lab solution. Also, it is good to know that if you haven't installed eve-ng, I have included a video on how you can install it on your computer. And just to let you know that eve-ng is a free software emulator that is much more powerful than Cisco packettracer. And the reason why I'm using it for this lab is because of the limitation that packettracer has. So enough of that, let's dive into the lab solution. Okay, so I'm going to tackle the first task from the lab task. And the first task is to enable LLDP globally across all devices in the network. However, there are subtasks, and the first subtask is to check if the LLDP is enabled by default or not. So I'm gonna log into switch one, and I would say show LLDP neighbors, and you can see that LLDP is not being enabled. If I go to router one and issue the same thing, so I'm gonna say show LLDP neighbors, and you can see that LLDP is still not enabled. So I'm gonna move to subtask B, where I'm gonna enable LLDP globally across all our network. So I'm gonna go back to switch one, and I'll go to configure terminal, and then I would say LLDP run. Let's do the same thing on switch 2. And do the same thing on router 1. And then again on router 2. And then on switch 3. And then on switch 4. Now let's do some in-flight checks. So I'll go back to switch 1, and I'll say show run pipe include LLDP. And you can see that we have configured LLDP there. Let's do the same thing for router 1. And again, the configuration has been taken because we can see it there. Let's move into the next step, and there we're going to actually execute the appropriate command to reveal the neighbors of each device. So let's start with switch 1. So I'm going to say show LLDP neighbor. And right now we can see that switch 2 is enabled. Just to let you know, guys, that one of the things that you would need to do as well when you are working with the eve-ng lab topology is that you will have to enable all interfaces on the router 1 and router 2, because by default they all shut down. So I'll go back to router 1, and I'll say show IP interface brief, and you can see that all interfaces have been already pre-configured with the appropriate IPv4 address. However, you can see that they are currently admin down. So I'm going to go back to global config, and I'll say interface range gig ethernet 0/0 all the way to 2, and I'm going to say no shutdown. And I'll do the same thing on router 2. Now let's wait for the LLDP to converge and go back to switch 1, and let's reveal the LLDP neighbors information. And this time we can see that switch 1 is a neighbor with router 1 and switch 2. And much like what we see with the CDP output, we can see the capability codes here. So for instance, the R is for router, B for bridge, T for telephone, etc., etc. So for instance, we can see these are the column headers of the table. We have the device ID, for instance, we can see switch 2 and router 1. The local interface, which is locally significant with regards to switch 1. So switch 1 is connected to switch 2 via gig Ethernet 00 interface. We can see that the default hold timer is set to 120 seconds, and the capability for each device switch 2 is operating in layer 3 switch, and the same applies for router 1 as well. And the remote end of each device is gig Ethernet 00, for instance, on switch 2, and the remote interface on router 1 is gig Ethernet 01. So we have already answered the first two questions of the second task, and the third question is regarding we need to execute the appropriate command to determine the neighbor's iOS type and version. So we will need to say show LLDP neighbors detail. And in here, as you can see, we have two neighbors. So the first neighbor is switch 2. And regarding the software, we can see here that is using virtual iOS layer 2 software. And the current software version is 15.2. And that pretty much answers the second question. Whereas the second output is for router 1. And you can see that is using iOS V software. And the current version is 15.6. You can see that the management address for router 1 is 192.168.10.10. Similarly with switch 2, the management IP address is 192.168.20.11. Okay, so next let's move into the third task where we are going to execute the command in question to reveal or display the LLDP global information. So to do this, we will need to execute show LLDP command. And here you can see that the status currently is inactive. The current advertisements are sent every 30 seconds, as you can see from that line. And finally, the LLDP hold time you can see is set to 120 seconds. So let's move into the fourth task. And the fourth task, we would need to issue the appropriate command to change the LLDP advertisement interval to 60 seconds. So I'm going to start with switch 1. So I'll go back to global config and I would say LLDP timer. If you question mark that, it will reveal the content sensitive help, and you can see these are the values that you can use, and I'm going to say 60. Let's do the same thing on switch 2. So regarding the question, why would you change the default settings? The answer to this is changing the LLDP advertisement interval is crucial if you have limited bandwidth. Increasing the timer to a higher value is one way to help avoid congestion in your network. So let's move into step 5. And step 5, we would need to change the hold down interval to 180 seconds. So since we are on switch 2, let's do that here. I'm going to say LLDP hold time 180. And let's do the same thing on switch 1. Regarding the question in task 5, why would you change the default settings for the hold down interval? First of all, we need to understand that the hold down interval for LLDP is to determine how long a receiving device retains LLDP information from its neighbors before it removes the entry from the LLDP table. We have already configured the timer with 60 seconds, which means the hello messages will be sent every 60 seconds. The current settings for the hold down timer is 120 seconds, which means if switch 1 or switch 2 didn't send a hello message 2 times in a row for whatever reason, switch 1 will declare switch 2 is down or dead and therefore will remove the LLDP entry from the table. This is one of the reasons why you should at least configure your settings such that if one of the devices didn't send a hello message 3 times rather than 2 times, then the neighboring device will declare that the switch is dead, and therefore it removes the entry from the table. So just be aware of the timer settings and configure it as you see fit. Okay, so with that being said, let's move to step 6, where we're going to perform some in-flight checks to verify our configuration. So I'm going to go back to privilege mode, and from there I would say show LLDP. And you can see that we've changed the LLDP advertisements from 30 to 60, and the same applies for the LLDP hold time. And you can see here we set it to 180. Let's do the same thing on switch 2. And we get similar output as well. Now let's move into step 7, where we're going to shut the Gig Ethernet 00 interface on switch 1. So I'll go back to switch 1. And from there, I'll go to global config. And then I would say interface Gig Ethernet 0/0. And I'm going to say shutdown. Let's just quickly do some in-flight checks. So I'll say show IP interface brief. And you can see that this interface is being down now. So let's move into step 8. So on switch 2, we would need to wait for the LLDP to converge. So let's go back to switch 2. Let's execute the show LLDP neighbors command. And you can see that switch 1 has been removed from the table as expected. So now let's go back to switch 1 and re-enable the interface again. And let's just verify that quickly on switch 2. You can see that we see switch 1 again from switch 2 perspective. Next, let's tackle step 10, where we're going to disable LLDP across all interfaces that are facing end hosts and the interfaces that are currently in the down state. So let's start with switch 1. So the first thing I'm going to do, I'm going to say show IP interface brief. And then I'm going to go to config terminal, and I would say interface range gig ethernet 0/2-3, and also gig ethernet 1/0 and gig ethernet 1/2 and 3. I want to say no LLDP transmit. Let's do the same thing on switch 2. No LLDP transmit. Let's do the same thing on switch 3 as well. and then finally switch 4. And then next, we're going to tackle step 11, where we're going to jump into routers 1 CLI and disable the LLDP under gig Ethernet 00. So I'll go to router 1 CLI, and from there, I'll go to global config, and then interface level config under gig Ethernet 00, and I will say LLDP receive. So I want to receive LLDP messages from my neighbor, which is in router 1, sorry, in router 2, but I'm not going to transmit any hello messages to my neighbor router 2. So I'm going to say no LLDP transmit. So if I issue on router 1, if I issue show LLDP neighbors, I should be able to see all 3 devices, switch 1, switch 2, and router 2. However, if we go to router 2 and issue the same command, you can see that right now I can only see switch 3 and switch 4. I can't see router 1 anymore. And the reason being is because we have disabled the LLDP messages from router 1 to router 2. Now let's initiate a ping from VPC1 to VPC4. So I'll go back to my topology and I will click on the VPC1. And from here, I would say ping 192.168.40.100. And you can see that we have successful ping despite the fact that we disabled LLDP on multiple interfaces. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.